Welcome to working against a spring. So here we first need to talk about what is the force exerted by a spring. So if X is the displacement from natural length, of the spring, so if here's our natural length, right, then X would be that little change, and it could be either extending the spring or shrinking the spring. And so Fx is the displacement from natural length of the spring. Then Hooke's law says that the force exerted by the spring is proportional to X. So in other words, F of X is equal to Kx, and K is referred to as the spring constant. And simply depends on the spring. So each spring will have its own spring constant, and we know that these are proportional. So we can use our knowledge of one situation to figure out kind of the general force, or sorry, the spring constant, and then the force from there. So for example, let's suppose that a force of 50 newtons stretches a spring 15 centimeters past its natural length to reach equilibrium. So let's start just with this first line. A force of 50 newtons stretches the spring 15 centimeters past its natural length. So we have when X equals 15 centimeters, or in other words, 0.15 meters, F of X is equal to 50 newtons. So we know that that should be equal to K times X. So I'm going to convert this to F of 0.15 is equal to 50 newtons. Right? We know that F of X is equal to K times X. So that means that we have 50 newtons is equal to K times 0.15 meters. That means that K is equal to 50 newtons over 0.15 meters. And I'm actually just going to leave that as 50 over 0.15. Or we could rewrite it as 5,000 over 15 newtons per meter, or 1,000 over 3 newtons per meter. So this is our K. So that first sentence tells us that F of X is equal to 1,000 over 3 times x. So note, all of this here comes from the first sentence. At this point, we now know our force in we now know our force equation. So from here, we can now use f of x to find work. Right? So we want to know, the question was, how much work is performed to stretch the spring those 15 centimeters? So essentially, to find work, and specifically, we want the work required to go from x equals 0, which refers to the natural length, to x equals 0.15, right? 15 centimeters past equilibrium. Sorry, it's 15 centimeters past the natural length. So we are looking at work is equal to, we are going to take the definite integral from 0 to 0.15 of f of x dx. This is, of course, the definite integral from 0 to 0.15 of 1,000 over 3 times x dx, which is just 1,000 over 3 times 1/2 x squared, evaluated from 0 to 0.15. So we are looking at 500 times 0.15 squared, and then subtracting off 0. And if I plug this in, I wind up getting, let's see, we have 0.15 squared is 0.0225 times 500 divided by 3 is 3.75. We were working with meters, so this is Newton meters, or 3.75 joules. So again, to figure out force with a spring, the very first step is to just figure out our spring constant. So step 1 is to find the spring constant. Once we have that information, then it's fairly quick to go from there. So step 2 is to determine the work. So find the work. So again, anytime we're dealing with springs, the very first thing you should do is find that spring constant. Once we know the spring constant, we know our force equation for any given displacement. And once we know force, we can then calculate work performed. So this is figuring out work performed in a spring, moving a spring. All right, in the next videos, we'll look at another variation of work word problems.